Okay, let's look at question 2. Question 2 says list 2 conditions of equilibrium on a system of forces. Now, there's quite a number of the conditions of equilibrium. The law of moments is only true when the system is in equilibrium. So you can say sum of the clockwise moments will be equal to sum of the anti-clockwise moments. And third law is also true when you have equilibrium system, which is the sum of the vertical components must be equal to 0. Sum of the horizontal components must be equal to 0. So I can just write in symbols here. Sum of the clockwise moments are equal to sum of the anti-clockwise moments, but you don't write in symbols. You write it in full, in words. Sum of the vertical components, must be equal to 0, and this means sum of the upward forces must be equal to sum of the downward forces. And then sum of the horizontal components must be equal to 0. This means forces eastwards must be equal to forces westwards. Okay. Then if you look at this question, question 2.2, you first had to sketch it up. You first had to sketch it up. Okay? Because then if you sketch it up, you're gonna see clearly. So I'm gonna say here is my true horizontal, and here is my true vertical. Okay. And then let's put the forces. It says the 3 kilonewtons west. So the 3 kilonewtons is this way, 3 kilonewtons. And then, no man, 3 kilonewtons west of south. It says west 35 degrees south. I'll just remove that one. So the 3 kilonewtons west of south, it's this way, 35 degrees west towards south. So the 35 degrees is here. That is the 3 kilonewton force. And then 2.5 kilonewtons east, 60 degrees towards south. East is here. So 60 degrees is here towards south. So there's a 60 degrees. This is the 2.5 kilonewton force. So this is north, that is east, that is south, that is west. And then the next force, 4 kilonewtons west. So west is 4 kilonewtons. And then 6 kilonewtons north. So north is up there, and that one is 6 kilonewtons. Okay. So here you will have components of the 2.5 kilonewton force. So the one component will run here, which is 2.5 cos 60. And then the other component will run down here, and it's 2.5 sine 60. Then for the 3 kilonewton force, you're gonna have a downward component, which is 3 sine 35. And then you're gonna have the horizontal component, which is 3 cos 35. Okay, so let's look at the sum of the horizontal components. Sum of the horizontal components. So your eastwards forces will be positive, 2.5 cos 60, this one. And that is all that is positive. Then the others are negative, minus 3 cos 35, which is this one, minus 4, which is this one. We minus them because they are facing to the west. So the answer here came as 5.207 kilonewtons. Because it's negative, you must indicate that it's going west. Then sum of the vertical components are equal to upward forces, a positive 6 is up. And then we have that force, which is downwards, minus 2.5 sine 60. And this one is also downward, minus 3 sine 35. Now, this one, when you put it in your calculator, you must make sure that you put the brackets, because if you don't put the brackets, sometimes it's got a tendency to say 6 minus 2.55, and then it separates, but it's not supposed to. The 2.5 is multiplying 6 sine 60 before you subtract. The first multiply out. So the answer here came as 2.114 kilonewtons. Because it's positive, it must go north. Okay. Then the last part, the magnitude and direction of the resultant. So resultant equals to the square root of the sum of the vertical components squared and sum of the horizontal components squared. Sum of the vertical components is 2.114. We square that. Sum of the vertical components is 5.207. We square that. So that gave us 5.620. That is just the magnitude. Then the angle, if you were to sketch this, the horizontal component goes west is 5.207. The vertical component goes north, so you make them follow each other like that, 2.114. Then this is the angle you are looking for. So that angle will be tan theta equals to opposite over adjacent. So tan theta will be 2.114 over 5.207. So theta will then be 2.097 degrees for you to get your full marks. Yeah. Then the next part is then to determine the magnitude and nature of the members CD and DE. Here, follow my notes because I'm showing you a summary there. And the summary says CD, because CD is on a slope, is going to be a strut. And the magnitude is going to be the force divided by sine of the angle. The force is 2 divided by sine 30. So 2 divided by sine 30 gives us 4 kilonewtons. And then the other one was DE. Then DE equals to a tie. Then the tie will be the force over tan of the angle, which is 2 over tan 30 degrees. That's going to be 2 divided by tan 30 will give us 3.464 kilonewtons. If you still have questions, feel free to contact me. Thank you.